Welcome to the first training mission for the RASBAM AV8B Harrier Night Attack aircraft. In this tutorial, we will go through the before engine start checklist, explaining the main functions of the systems. Throughout the training, you will be required to press spacebar to indicate that you are ready to proceed to the next step. The instructions will be visible on the screen until you do so. You can take as much time as you want at each phase. Let me know when you're ready to begin. The AV8B Harrier Night Attack aircraft is a transonic, day and night, tactical ground attack fighter built by McDonnell Douglas Aerospace. It entered service with the United States Marine Corps in 1991 and is still in service today. The Harrier features high shoulder-mounted swept wings with leading-edge root extensions, or LERCs, and automatic maneuvering flaps that aid maneuverability at high angles of attack. The aircraft has overall positive dihedral, aerodynamic, and high lift characteristics, enabling it to carry a deadly array of general-purpose and precision-guided munitions on its 7 external stations. The Harrier has 7 internal fuel tanks with a capacity of 7,759 pounds of fuel, and its range and endurance can be increased with the addition of up to 4 external wing tanks and/or the use of probe and drogue aerial refueling. The aircraft is powered by a Rolls-Royce F402 RR408B Pegasus non-afterburning turbofan engine that provides 22,200 pounds of dry thrust. The F402 engine also has thrust vectoring exhaust nozzles that enable the aircraft to perform its signature vertical or short takeoffs and landings at sea or forward bases close to the front lines. A water injection system used for heavy VSTOL operations lowers the jet pipe temperature and increases the thrust, for a short period of time, to up to 23,400 pounds. Flight controls are hydraulically powered to provide the desired effects throughout the Harrier's speed range, and a reaction control system, or RCS, diverts engine bleed air through the nose, wing, and aft puffer vents for attitude authority in jet-borne flight. The cockpit is divided into 3 major areas. The left console, from aft to fore, contains the oxygen monitor panel, fuel shutoff handle, pilot services panel, external lights panel, exterior lights master switch, fuel panel, throttle quadrant, stability augmentation attitude hold system, or SAS, and trim panel. The main instrument panel, looking from left to right, contains the landing gear flaps control panel, the combat water panel, the armament control panel, the master armament panel, the left and right multi-purpose color displays, the option display unit, ODU, the heads-up display, HUD, the upfront control, UFC, and HUD control panel, standby flight instruments and indicators, the FLIR power panel, miscellaneous power switch, the circuit breaker panel, the warning lights panel, the engine display panel, the fuel quantity indicator, the electronic countermeasures or ECM panel, the clock, and the brake and hydraulic pressure indicators. The right console, from fore to aft, contains the electrical panel, the VHF-UHF radio set control, the auxiliary communication navigation identification panel, or ACNIP, the interior lights control panel, the environmental control panel, the NVG stowage compartment and video recorder, and the ground power panel. The aircraft should be pre-configured by the plane captain prior to entering the cockpit, but it is important to conduct your own pre-start checks. These checks are performed in a left-to-right flow, beginning with the DEX enable switch. DEX enable switch should be set to off. DEX stands for Digital Engine Control System and is responsible for proper functioning of the engine. Make sure that the fuel shutoff handle is also set to off at this stage. In this position, the fuel system is completely isolated from the engine. Move forward to the pilot services panel and verify that the engine RPM select switch is set to low, indicating the low pressure fan RPM on the engine display panel. Selecting high displays the high pressure compressor RPM. Now set the engine fuel control or EFC switch to position 2. This switch determines which digital engine control unit, or DECU, will control the fuel metering unit responsible for the correct fuel flow into the engine. Next step is to verify that the Lift Improvement Device System, or LIDS, is in norm position. LIDS is a retractable fence that, when deployed, increases the vertical lift by directing the hot jet stream energy. It is part of your landing gear system. Good. Now check that the oxygen switch is set to off. This switch controls the operation of OBOGs, or onboard oxygen generating system. Let's move to the H2O dump switch and make sure it is set to off. As the name implies, you'll want to use it to empty the 500-pound tank of distilled demineralized water. Water injection allows you to temporarily increase the engine RPM during takeoffs and landings. Moving to the external lights panel, ensure the formation, position, anti-collision, and auxiliary landing light switches are set to off. Verify that the air refueling switch is in the in position. This pressurizes the fuel transfer system, transferring fuel to each center tank in series from all tanks in the group at the same rate that the fuel is being consumed from each group. The left and right dump switches should be set to norm. This powers the left and right fuel jettison valve motors. Now ensure the left and right pump switches are set to norm. These energize the left and right AC boost pump relays located in the lower portion of each center feed tank. Check that the fuel flow proportioner is set to on. This powers the fuel flow proportioner, ensuring equalized flow of fuel to the engine between the Harrier's two feed groups. Next, ensure the throttle is fully aft in the off or idle cutoff position. Verify that the jet pipe temperature limiter is set to on. This ensures that the deck's JPT limiter function is not muted. The JPT limiter uses thermocouples in the turbine exhaust sample gas temperature to limit the RPM in different configurations. Now ensure that the manual fuel switch is set to off. The manual fuel system provides an alternate means of control if the primary fuel control system fails. It directly controls engine RPM and contains no automatic compensation, controls, or limiters. In the off position, engine control is performed by the decks. Ensure the parking brake is aft in the on position. The parking brake applies approximately 3 hours of brake pressure in the system and prevents the throttle lever from moving past it while the lock is engaged. On the stability augmentation and attitude hold system panel, set the pitch, roll, and yaw stability augmentation system switches to on. Set Q-feel to the on or Q-feel position. Q-feel provides artificial longitudinal force feedback due to the primary flight controls being entirely hydraulically powered. Set alt hold and AFC switches to off. This disables both altitude hold and automatic flight control modes, which will be covered in a later lesson. Set the rudder pedal shaker yaw switch to on. Rudder pedal shakers give an early warning of side slip at low speeds. The shaking pedal should be pushed to counteract the side slip. Set the landing light switch to off. There are two landing lights, a 250 watt filament for landing approaches and a 150 watt filament for hovering. Next, move to the landing gear flaps control panel and set the anti-skid switch to on. Anti-skid controls hydraulic pressure to the brakes and prevents skids above 16 knots and partial skid protection between 16 and 8 knots. Note that the anti-skid is inoperative while the parking brake is engaged. Check that the landing gear handle is in the down position. Check that there is no white band showing at the base of the landing gear emergency battery handle, which would indicate that the battery has been previously fired. Next, verify the flaps switches are set to auto and off. Off disables power to the flaps mode switch, and auto provides 25-degree flaps with the landing gear handle in the down position. At the lower left of the main instrument panel, ensure the water switch, labeled H2O, is in the center off position. This prevents water from being injected into the engine. Verify that the master arm switch is off. On the Armament Stores Management Control Indicator, ASMCI, verify that the selective jettison knob is set to safe, and the manual release control knob is set to norm. Safe prevents selective jettison of stores and suspension equipment. Verify the IR cool switch is off. IR cool begins cooling infrared sensors and stores. Ensure the multi-purpose color display, MPCD, is off. The MPCDs, often referred to as the digital display indicators or DDIs, are 5x5 inch CRT displays surrounded by 20 multifunction push buttons. These push buttons are numbered 1 through 20, beginning with the bottom button on the left side of the panel and counting upward in a clockwise direction. They are turned on and off with the brightness knobs located directly above them. Set the head-up display or HUD brightness knob as desired. The HUD is the primary attitude indicator, weapon status, and weapon delivery display. It displays collimated symbology and is electrically interfaced with the upfront control and HUD camera. Set COM1 and COM2 volume by rotating the knobs to the 12 o'clock position and adjusting as necessary. Set UFC brightness as desired. Verify the clock is set to the proper local time. Next, bring your attention to the miscellaneous control panel. This may be obscured behind the stick. Verify the FLIR switch is set as desired for the mission. For now, leave this switch in the off position. Set the video recording system, or VRS, switches to the auto and HUD positions. Auto mode commands the mission computer to turn on the video recorder when air-to-air, AA, or air-to-ground, AG master modes are selected. HUD records the HUD camera. Set the dual mode tracker, DMT switch as desired for the mission. The DMT allows the pilot to track a pixel contrast TV image, or coded laser energy, for target acquisition and attack runs. For now, we can leave the switch in the off position. Verify that the inertial navigation system, or INS mode selector knob is in the off position. The INS is coupled with the aircraft's GPS to provide accurate aircraft and targeting system coordinates for navigation and attack. The INS will be covered in more detail in a later tutorial. Ensure that the display computer, or DP switch, remains in the auto position. This switch controls selection of redundant display channels that drive the HUD and DDI. Auto is the default mode. Next, ensure that the mission computer, or MC switch, is also in the auto position. In the event of a mission computer failure, auto will allow the display computer to be used as an emergency backup. Finally, verify that the probe heat, PRB, switch is set to auto. This switch energizes the various probe sensors on the aircraft, and auto mode removes power from all heaters except the angle of attack case heater with weight on wheels. Once airborne, all probes will receive heat. Below the miscellaneous switch panel, verify that all circuit breakers are in the in positions. There are 7 circuit breakers controlling aileron trim, stabilator trim, rudder servo, flaps, speed brake, landing gear, and the right probe heat. Now draw your attention to the electronic countermeasures panel on the right front dash. These switches control radar warning receiver, expendable modes, and electronic countermeasures and will be covered in detail in a later lesson. For now, leave these switches in the off position. Let's move on to the right console now. On the electrical panel, verify that the battery switch is set to off. The battery switch powers the ground service, switched battery, jettison, alert, and emergency 28-volt DC buses with generators and transformer rectifiers offline. Set the generator switch to Gen. The main generator is an engine-driven 30,000 volt ampere, variable speed, constant frequency generator which provides 115/200 volt, 3-phase, 400 Hz AC current to the aircraft main and essential AC buses, and to both the main and standby transformer rectifier units, or TRUs. In this setting, the aircraft generator will automatically come online when the engine reaches approximately 23% RPM. Failure to set this switch may result in a dual DEX failure during engine start. Next, set the VHF/UHF radio remote control on the Auxiliary Communication, Navigation, Identification Panel, or ACNIP, to transmit/receive, or TR. Configure the rest of the ACNIP to suit your assigned mission. At a minimum, verify that the mode switch is set to the upfront control, or UFC, to set primary control of your ARC-210 radios to the UFC, and verify that the identification friend or foe switches are set to norm. On the internal lights panel, set the compass, instrument console, flood, and warning caution lights knobs as desired to suit the environmental conditions. Now, on the Environmental Control or ECS panel, set the temperature controller to auto. This electronically regulates the cabin temperature. Verify the equipment bay cool switch is set to on. This sends bleed air through a RAM air-cooled heat exchanger to the aft equipment bay housing most of the aircraft's avionics equipment. Verify the defog switch is in the norm position. This diverts a portion of the cockpit airflow away from the pilot to the windshield defog ducts. Finally, verify that the cabin pressure switch is also in the norm position. This opens the cabin pressure regulator and discharge valve on the forward cabin bulkhead, maintaining a constant cockpit pressure altitude of 8,000 feet, at altitudes between 8,000 and 23,000 feet, and a constant 5 psi pressure differential greater than ambient pressure above 23,000 feet. That covers the after entering cockpit checklist and cockpit familiarization tutorial. You may now continue to the cold start part of the training. In this mission, we will start the engine, conduct the post-start before taxi checks, and finish by taxiing to the designated warm-up area.
Chief, turn on the ground power.
Copy. Ground power is now on.
As you have learned in the previous mission, the aircraft should be pre-configured by the plane captain and then checked by the pilot. During these checks, you should at least take care of the following steps. Ensure the left and right pump switches are set to norm.
Set.
Ensure that the display computer, or DP switch, remains in the auto position. Next, set the VHF/UHF radio remote control on the Auxiliary Communication, Navigation, Identification Panel, or ACNIP, to transmit/receive, or TR.
Set.
Place the battery switch to BAT position. Look for a voltage of at least 24.5 volts in the battery voltage indicator in order to start either the APU or the engine. Conduct a test of the warning and caution lights by holding the compass lights/lights test switch in the lights test LTS test position. Look around the cockpit to ensure all the warning, caution, landing gear, combat switch panel, HUD master mode, in-flight refueling, and threat lights are operational. Note that your warning, caution, and advisory lights are not operational in the aircraft until this test is performed, and that not all lights are capable of illumination on battery power. Press the master caution and master warning buttons to reset the priority caution lights and turn off the voice warnings. Following this test, ensure that the oil light is illuminated, indicating low oil pressure and a properly functioning sensor. Next, make sure the landing gear indicator on the left console shows forward gear down and locked.
Fuel control, generator.
Checking the aircraft's two igniters is done two ways. First, signal the plane captain to position themselves near the left intake to listen for the first igniter. Press the air start button on the throttle to activate the igniters and listen for an irregular crackle, indicating that both igniters are firing. Note that both boost pump lights should extinguish during this check, since the DC portion of the boost pumps is active while they fire.
Air start button. Engine air start. I think I can do that here. Okay.
At the conclusion of the first test, the plane captain will automatically position themselves to listen for the second igniter. Select the manual fuel system, or MFS, switch to on. Listen again for the irregular crackle and watch for the boost pump lights to extinguish. Select the MFS switch to off when complete.
Manual, fuel, manual, fuel. Manual,
Yep.
fuel, manual.
Perform a built-in test, or bit, of the engine display panel, or EDP, by pressing the bit button at the upper left of the EDP. Watch for the tumblers to rotate through available numbers, and the overtemp, 15-second, and water flow lights to illuminate. After a successful bit, all lights will extinguish and the nozzle indicator will return to between 0 and 10 degrees. Place the DEX enable switch and fuel shut-off handle into the on position. Perform a fuel panel bit by setting the bingo bug to 4,000 pounds or greater and turning the selector knob to bit and holding it in position. The left feed group will indicate 1,400 plus or minus 100 pounds. The right feed group will indicate 2,400 plus or minus 100 pounds, and the totalizer will read 3,800 plus or minus 200 pounds. The master caution, left and right full advisory lights on the arch, left and right, and 250-pound flashers, left fuel and right fuel, will flash. The load and bingo caution lights will also illuminate. Return the selector knob back to total or INT position and set the bingo bug to the briefed value. Next, let's close the canopy in preparation for an APU, or translation start. Pull one of the handles. The lock will engage automatically once it's in full forward position. Watch for the canopy caution light to extinguish. Signal the plane captain that you will be conducting an APU start. This method is useful when you need to use the APU to recharge a low battery, you require use of the radios early, or when you need to conduct a lengthy system entry prior to engine start and don't want to consume an already limited quantity of fuel in the process. A translation start leverages the fact that the APU is already on to power the gas turbine starter, or GTS. Place the APU generator switch in the on position. Watch for the standby transformer rectifier unit, standby true, light to illuminate momentarily and for the APU light to remain on. Prior to engine start, we will conduct a digital engine control system, or DEX, power check by moving the DEX enable switch to off.
Caution.
Look for the electronic fuel control, or EFC, and JPTL warning and caution lights to illuminate. Return the DEX enable switch to the on position.
Fuel control. Caution, caution.
Cycle the EFC switch to position 1. Your EFC caution light should momentarily flash with an associated audible alert.
Caution.
This verifies that the redundant digital electronic control unit, DECU, is functional prior to starting the engine. Reset the switch to position 2. If external power is connected, signal the plane captain now to remove the power cable and wait for confirmation that it is disconnected.
Chief, turn off the ground power.
Copy. Ground power is now off.
Place the engine start switch in the forward engine start position. Listen for the APU to decelerate for 10 seconds before the GTS engages to start the engine.
Caution, caution.
When RPM reaches approximately 3%, bring the throttle into idle position. Engine light is indicated by a jet pipe temperature rise and rapid RPM increase. Check that the start switch automatically shuts off prior to 15% RPM.
Caution.
Verify that the engine idle RPM stabilizes between 28.4 and
Hey, what's the
29%,
throttle?
and that the JPT is below 545 degrees Celsius.
Caution, caution.
Now, check that the hydraulic 1 and 2 and brake accumulator gauges read 3000 plus or minus 200 psi. Fully depress the toe brakes and verify that the brake pressure gauge reads a minimum of 2700 psi. Place the nozzles at 10 degrees to reduce excessive wear on the tailplane and flaps. Now that we are on engine power, conduct another lights test by holding the compass light/lights test switch in the aft LTS test position for about 5 seconds, waiting for the lids caution light to illuminate. This delay is to check the electrical circuitry on the lids fence. Upon release of the compass light/lights test switch, all remaining lights indicate a current condition of the aircraft. Once again, check the landing gear panel. You should see 4 green lights indicating all gear are down and locked. Turn on your MFCDs by rotating the off/bright knob at the top of each panel clockwise and selecting day or night as appropriate to the current lighting conditions. Turn on your HUD by rotating the bright knob on the HUD control panel clockwise, setting the brightness as desired. Select Norm on the Norm/Reject 1/Reject 2 switch and select the desired mode with the Day/Auto/Night switch as appropriate. On the UFC, turn on both radios by adjusting the volume knobs as desired. Set the bright knob to a level that allows you to read the ODU, scratch pad, and COM channel windows in the current lighting conditions. To monitor the engine, press the push button 18 twice, and then select Engine with push button 11. Check that your inlet guide vane or IGV angle is between 31 and 39 degrees at idle RPM, and press the Jet Pipe Temperature JPT button with push button 10 to reset the sortie JPT to the current indicated temperature. Once the engine is started, you may open the canopy.
Caution, caution.
The next step prior to taxi is to begin the inertial navigation, or INS, alignment process. First, verify that the parking brake is set. Now, verify the aircraft's position by pressing the push button 18 and then push button 2 twice. First to enter the EHSD and then to the data page. Once there, press the AC button or push button 16 to update the aircraft position. You will notice a string of 6 zeros on the scratch pad. Use the keyboard to choose N or S hemisphere and then introduce the full sets of coordinates. You will find these in your kneeboard. Press Enter when you are ready. Now press the position button once again. This time press 4 for west or 6 for east and once again type in your coordinates. Don't forget that this time you'll have to introduce 6 digits. Press Enter when you are ready to continue. Last thing you need to do is set the magnetic variation. Press the Mag V button on the ODU, press 6 to choose east and then type 006 and press Enter.
Ja, maar ik was nog niet zo ver.
Begin ground alignment by rotating the INS knob clockwise to the ground align setting and ensure the MPCD initiates with quality ATT not OK and time counting upward. After approximately 1 minute, you will notice the qual counting down until it reaches 0.7.
En dan 041 51 27 east. East 041 51 27, enter. North 415537, enter. Then magnetic variation is 6.1. No. Why is it still doing east and I don't get this. No, 04. Oh my God! East 041 51 27. Enter. Yeah, it's, I don't know what it's doing. Yeah, it's all good. And that's good. All right. I think we got that.
Place the DMT switch in the DMT or on position to power on the dual mode tracker. Press the TCAN or TCN button and press the on-off button, verifying the ODU is set to transmit/receive.
Caution, caution.
TCAN.
Press the altitude or ALT button and press the on-off button to activate the audible alert. Return to the miscellaneous switch panel and power on the FLIR by placing the FLIR switch in the FLIR or on position. The FLIR sensor will begin its cooldown period. Next, we will conduct a JPT limiter check. Place the JPT switch in the off position and observe a rise in RPM, fuel flow, and jet pipe temperature on the EDP, as the aircraft switches from short-lift dry schedule and limit to the short-lift wet schedule and limit. You will hear an audible warning and observe JPTL flashing on the master warning panel.
Limiter off, limiter off.
Cycle the EFC switch to position 1. Your EFC caution light should momentarily illuminate and extinguish with an associated audible caution. Reset the switch to position 2. Return the JPTL switch to the on position and observe the associated drop in RPM, fuel flow, and jet pipe temperature on the EDP. Conduct a manual fuel system or MFS check by placing the momentary manual fuel man fuel switch behind the throttle in the on position. Listen for the audible caution and observe the MFS light to illuminate on the master caution panel.
Manual, fuel.
Place the momentary man fuel switch in the off position and observe the MFS light on the master caution panel extinguish. Now we will check the water injection system. Place the water switch in the takeoff position and observe an increase in RPM, fuel flow, and jet pipe temperature as the deck switches to the wet datum. Return the H2O switch to the off position and observe a return to normal idle RPM. Now place the H2O switch in the landing position and observe the same indications as the takeoff position. Return the H2O switch to the off position and observe a return to normal idle RPM. Next, we will check the Enhanced Variable Inlet Guide Vane Control System, or EVIX. First, release the parking brake. Then, select the ENG page with push button 11. Hold your brakes and advance the throttle to 55% corrected high pressure compressor RPM and then return the throttle to idle. Press the menu button with push button 18, press the bit button, and observe that there are no error codes in the IGV system. Next, set your parking brake. Conduct a trim check by trimming the aircraft's rudder and ailerons left and right through their full range of motion and verifying an appropriate response on the rudder and aileron trim gauges.
Where are these trim gauges? Oh, underneath the... well, that's gonna work. Yeah, I can't watch these. I don't see them.
Cycle the stabilator trim through its full forward and aft range of motion, verifying an appropriate response on either the EDP or AMPCD engine page. Set the stabilator to 4 degrees nose down. This keeps the front RCS duct closed so that you don't inadvertently blow foreign object debris, or FOD, into the engine intake while taxiing. Check your standby instruments by verifying they match other indicators in the cockpit. Uncage the attitude indicator 1 minute after power was applied to the gyro. Turn the cage knob to set the proper attitude. Set the barometric pressure on the altimeter and make sure the barometric altimeter matches the airfield elevation listed in the kneeboard.
feet, whatever.
Next, enable the onboard oxygen generating system, or OBOGS, by moving the oxygen switch to the OXY, or on position. Now it's time to begin the one-finger check, or flaps bit. Set the flap switches to on and auto. Pass the one-finger signal to the plane captain and press the flaps bit button on the landing gear control panel. The master warning light will illuminate and the flaps position indicator will fluctuate, indicating that the flaps bit is being conducted. When complete, your flaps caution and warning lights should extinguish and your flaps should be at 25 degrees. Place the flaps mode switch to the short takeoff and landing, or STOL position, and verify that the aileron droop light eliminates. This indicates that the aileron neutral positions are set to 15 degrees down, producing greater lift in slow speed regimes. Set the flaps mode switch to cruise, watch that the droop light extinguishes, and verify the flaps position at 5 degrees. Two-finger checks verify proper response from the flight controls. Pass the two-finger signal to the plane captain and then move the flight controls through their full range of motion, starting with full left and right rudder deflection. Next, check stabilator by pushing the stick full forward and checking the EDP stabilator position at 11 degrees down. Pull the stick full aft and check the EDP stabilator position at 10 degrees up. Finally, check aileron function with full left and right deflection, ensuring that you can visually see the up aileron above the plane of the wing. Three-finger checks test the stability augmentation and attitude hold system, or SAS. Pass the 3-finger signal to the plane captain and initiate the SAS bit from bit 1 page on the right MPCD. Press the SAS button, push button 12, and observe the test appear next to the SAS legend, as well as the illumination dep res, pitch, roll, and yaw caution advisory lights. A successful bit is indicated by all lights extinguishing. Next, conduct a stores bit check and review the Stores Management System Function Failure, or SMSFF page. Select Menu on push button 18, then Stores on push button 4, and look for any weapon failures or flashing weapon fail indications. Conduct a check of the display processor function by cycling the DP switch between primary and alternate. Set the switch back to auto, which will randomly select an operational channel and provide automatic reselection upon channel failure. Four-finger checks test the air refueling probe for function. Pass the 4-finger signal to the plane captain and extend the air refueling probe by moving the AR switch to the out position. Look for the green ready light on the left canopy arch and retract the probe by moving the AR switch to the in position. Verify that the green ready light extinguishes. Before we can take off and subsequently land, we need to verify vertical landing aircraft performance against the aircraft's weight, current environmentals, and the dimensions of the selected runway surface. This is done through the vertical takeoff, vertical landing, range endurance, speed, and time computer. This is also called the VSTOL rest, or just the VREST for short. Press the VREST button on push button 8 and check the basic aircraft weight, water weight, and basic drag index, or BDI. Box the vertical landing page on push button 6 and verify the outside air temperature, or OAT, field elevation, and gross weight of the aircraft. The GW is the sum of the BAW, fuel, water, and external stores and should be equal to the amount listed on your kneeboard. Next, adjust your cockpit lighting and set your displays. Set your left MPCD to the Electronic Horizontal Situation Display, or EHSD, by returning to the menu page with push button 18 and pressing the EHSD button. Set your right MPCD to the Forward-Looking Infrared, or FLIR page, by returning to the menu page with push button 18 and pressing the FLIR button. Configure the HUD with the HUD control panel beneath the UFC. For now, set the HUD mode to day, adjust the HUD video brightness and contrast as desired with the video brightness and contrast knobs, and raise or lower the seat until the upper combiner glass barely cuts the heading numerals in the VSTOL HUD display mode. Next begins the final checks before taxiing the aircraft for takeoff. Signal the plane captain, verify that the parking brake is set, and turn the anti-skid switch to on. Check the EHSD for proper INS alignment. The goal for INS alignment is a qual readout of less than 1.0 with an OK indication. Rotate the INS switch to the in-flight alignment, or IFA position, once the aircraft has a satisfactory alignment, and verify a tightly coupled GPS and INS with a position/INS indication at the lower right of the EHSD. Verify that the aircraft is properly configured for taxi by checking that it is in VSTOL HUD master mode, nozzles are set to 10 degrees, flaps mode is in cruise, flaps position is 5 degrees, and the aircraft is properly trimmed 4 degrees nose down.
Flaps mode in cruise. Flaps mode is in cruise. Nozzles set to 10 degrees. Flaps pulse is 5 and 4 degrees nose down.
Next, select APU on or off as desired. Since it's daylight and the skies are clear with good visibility, we will leave it off. Test the brakes and nose wheel steering by moving the anti-skid switch to the NWS position and obtain taxi clearance from ground.
Caballetti, in field, 1. Request startup. Caballetti, in field, 1. Request startup.
Apparently my radio isn't set up correctly. 1330. Let's see if I can figure out how to do that. 133. That's preset. 1330 is not even on here. Manual. I should be able to do that here, right? Uh, 133. That is not correct. Why is it not setting to 13300? There.
Caballetti, in field, 1. Request startup.
Enfield 1. Caballetti, cleared for startup. Wind 0.
Okay, taxi to
Couple
the
ready.
runway.
Infield 1. Request taxi to runway. Enfield 1. Couple ready. Clear to taxi to runway 25.
Release parking brake.
Caution, caution.
Oh, chocks. Chocks! Parent menu, ground crew, wheel chocks, remove.
Chief, remove the wheel chocks.
Copy. Wheel chocks are now removed.
Release the parking brake and brake pedals and begin to taxi forward. Tap the pedals to verify proper operation of the brakes.
Brakes checked.
With the aircraft slowly rolling forward, press the undesignate/NWS pinky button on the stick to activate a high gain NWS and saw the pedals left and right to verify proper function and range of motion of the NWS system.
Checked.
Release brake pressure and begin rolling to a speed of about 15 knots. Follow the taxiway line and turn left, being careful not to ride the brakes.
Oh,
As you leave the line,
right.
bring the nozzles to 0 degrees. Even at idle power, you can start to build up excessive ground speed. Counter this with smooth, periodic brake pressure. Avoid the impulse to ride the brakes, and bring the nozzles to 30 to 40 degrees to control your speed if necessary.
So he wants me to go left then. Alright. Left it is.
As you approach the active runway, smoothly apply brake pressure and come to a stop toward the edge. Set your parking brake and deselect NWS by placing the anti-skid switch in the on position. Verify the skid caution light extinguishes. That covers the starting engine before taxiing and taxiing checklists. In the next lesson, we will cover pre-positioning checks, a conventional takeoff, and basic handling drills.